Hello everyone. I am going to answer some questions that came up on the discussion board and review for the exam. I think the first thing I should say is I was a little bit disappointed that there were only 3 questions. I was expecting to see something like 20, 25 questions, and then I would have to choose which ones to answer based on what people were voting for. And there's only really 2 possible ways that could happen. Either everyone else already understands it, or everyone else hasn't really engaged with the review material yet. My sense, based on some of the quiz results, is that it's the second option, that many of you have not engaged with this yet. And I think that is understandable based on the fact that you had a big homework assignment due last night. So some of you might be otherwise engaged and not able to participate right now. However, I highly encourage you to at some point take the practice exam before, I would say at least the day before we have the actual exam, so that you are aware of what areas you need to do better on. Also, I would highly encourage you to at some point post something to this particular discussion board. This is the easiest 2 points you'll get all semester, I guess, until we have the discussion board for the second exam. But there's a lot of ways you can respond, and you'll get credit for any of them. I will try to answer questions that come up from here on related to the practice exam. I cannot promise that I will be able to make a video answer key for them. I probably will not be able to, but I can try to answer those questions, and it is possible I could do maybe one quick video tomorrow afternoon, depending on how the rest of my day is going. I have a lot of other things going on Wednesdays. Okay, so let's look at these questions. The first question, I'm just gonna go in the order that they are on the exam. Was question number 5. So I'll go ahead and read this and talk about how to answer it. So the question is: an irregularly shaped piece of aluminum has a mass of 35.65 grams. I'm going to underline that. That's probably going to be important. What volume in milliliters, I'm going to underline milliliters, of water should it displace if it is solid all the way through? Aluminum has a density of 2.7 grams per cubic centimeter. I'm going to underline that. Okay, so I'm going to go through and write down these numbers and things we've identified in the question. So first thing is I'm going to write milliliters with a question mark, because that is what we're looking for. I'm going to write mass is equal to 35.65 grams. That's something we know. I'm going to write for the density, I'm going to write it in this way. I'm going to write it as 2.7 grams equals 1 cubic centimeter. I'm writing it in that way because it's this ratio can be written as an equality, and we'll use that as a conversion factor as necessary in the question. So we are given grams, we're given a conversion factor that does include grams. We're looking for milliliters. There's one additional piece of information we need to solve this problem, and that is to remember that 1 milliliter is equal to 1 cubic centimeter. Okay, so that's the one piece of information that's not given here. So what we're going to do at this point is we're going to set this up as a series of conversion factors and see how the units cancel out for us. So we'll start with the thing by itself. So the mass is by itself 35.65 grams. And then we will look for where can we cancel out the units of grams. We have grams in this this equality, so we'll put the grams on the bottom, so 2.7 grams on the bottom, 1 cubic centimeter on the top, And then we have this equality as well. 1 milliliter is equal to 1 cubic centimeter. And we're looking for milliliters, so if we do the math there, we should get what we're looking for. So let's go ahead and do the math. I'm going to just do this on my phone. So 35.65, and we divide that by 2.7, and that equals that number. So my calculator says 13.2 milliliters. Based on what we're given, we would round that to 13 milliliters for the best answer for this question. Now the question itself does not specify significant figures, so I probably would not mark you off if you had left it at 13.2. But that's how you solve that first question. I wanted to also, actually let me just mention this really quickly. So there was some discussion on question number 7. I thought the student response to that was really great. I don't think I have much to add to that response. So unless there's additional questions, I think I would refer you to that response as a good response to this particular question. I'll also go ahead and say here on the video that this is the kind of the level of depth to expect on a question related to heat and heat capacity. I know we had more detailed questions in the lab, but you will not see something that detailed on the exam. And then one other thing, I'm not mentioning students by name here, of course, because this is on the internet and I want to respect your privacy. So the last question that we had was number 18. So I will go ahead and read this and then we'll solve the problem. How much energy is released when 3.66 grams of nitrogen monoxide, okay, that looks important, forms from the following reaction? And then the other thing is how much energy is released. Okay, so we're looking for delta H released. Okay, so that's what we're trying to find. The other thing we're given is a mass of nitrogen monoxide, so that's NO. One other thing I'll mention here, so this is partly nomenclature recognizing nitrogen monoxide as NO. At the same time, when you are given a sentence with the name of a molecule or element, and you also have the balanced equation, if you're not sure of the identity of this, you can look at the balanced equation and see which one makes the most sense. So nitrogen monoxide is probably not H2O. So you can kind of narrow it down based on looking at that reaction. Okay, because we are looking at NO, this is probably important. So we have 4 moles of NO, and what do we care about that 4 moles of NO? We care about the energy involved. Okay, so the energy involved there is written over here. So 4 moles of NO is equal to negative 906 kilojoules. Okay, the other thing we're going to care about is that we have NO and we have grams, so we probably will need a molar mass. So let me actually go ahead. I know all of you are excellent at finding molar masses by now, but just to be thorough, let me go ahead and go through how to find that on the periodic table. I'm going to look at this. This is the periodic table on the practice exam. You will have one very similar on your exam. So nitrogen, oxygen, we add those together. So I'm going to round that to 14.01. So if you have 2 decimal places, that's fine. So we round that up to 14.01. Round that up to 16.00. So that gives us 30.01 grams per mole. Okay, so that's the molar mass of NO. So let's go ahead and write that down here. We can write 30.01 grams equals 1 mole. of NO. Okay, so let's go ahead and go through this. So we have equality, what we're looking for, number by itself. We start with the number by itself. So 3.66 grams of NO. We're starting there. We look for which of our equalities has units grams NO. We see that down here. Okay, so this one. So let's use that one next. We have 1 mole of NO is 30.01 grams. Okay. One thing I want to emphasize here, I have seen this come up on some of the discussion board questions recently. When you're doing this mole to mass calculation, you are not looking at the stoichiometry in the balanced equation. So this is the same thing that we did way back in Module 5. So so you know how to do this already. We're not changing this step based on what we've learned in this chapter. And this, I should say, the most recent chapter. And then we have moles. We have moles of NO here. Again, important that the units are the same. So moles NO, moles NO. So we put those so they will cancel. So 4 moles of NO on the bottom. Negative 906 kilojoules on the top. Okay, let's go ahead and look at our units. Grams of NO cancel, moles of NO cancel, and we are left with kilojoules. So let's go ahead again and do the math. I will bring my my phone back out here and we can go through the math. So we have 3.66, so we're multiplying everything on top, so times 906 negative, and then divided by 30.01 equals divided by 4 equals. So we multiply everything on top, then divide on the bottom, and we get negative 27.6 kilojoules. Okay, so that is our answer. Negative 27.6 kilojoules. Now you might say, why is it negative? Do I have to, do I have to care about the negative sign? The negative sign is important here, and this is consistent with the energy being released. Energy being released is exothermic. We have energy being released here. This is an exothermic reaction, so one of the important things you'll need to know related to this sort of question is that these are, negative is showing exothermic, release is showing exothermic. You're not going to have a question where those will contradict each other, but just be aware that that understanding definitely will be important for this upcoming exam. So that is it for the questions I was given so far. Feel free to keep asking questions. I may or may not be able to make a video, but I will, at the very least, try to answer them. Happy studying, good luck studying, and good luck on the exam.